All right, the next topic we're entering into is solving quadratic equations, finding square roots, and the whole next couple sections are leading up to that quadratic formula and using square roots and that kind of stuff. And so so this will all link together eventually, even though at times it's going to feel a little bit disjoint. This first one is just some basic quadratic equations that we're going to use, and the kind of whole of the whole thing is when I have something like 2x squared minus 16 equals, let's say 34, and I add 16 to both sides, I get 2x squared equals 50. Divide by 2, I get x squared equals 25. What number squared equals 25? Well, 5 squared could equal 25. You know, if you square root both sides, your calculator will tell you 5. But you do have to be careful because negative 5 squared could also equal 25. So the answer to this question here would end up being 5 and negative 5, or 5 plus or minus 5 is kind of how we write that. So you have to be careful. When we talk about square root, that's just that symbol. When we square root something, right? Find what number squared equals it, I guess would it be. And when we look at a radical sign, that's called the radical sign. The radicand in this situation, if I were to square root 25, 25 would be the radicand. And when we rationalize the denominator, the one thing you need to know about math, it's one of those silly rules that we have, like you can't have 0 on the bottom of a fraction. The other thing you can't have on the bottom of a fraction is the square root. So you could never have something like 4 over the square root of 10. You can't have square root on the bottom. And so what we end up doing is multiplying the top and the bottom by the square root of 10, and we get 4 square roots of 10 over 10. And then obviously you can work with that from there and call it 2 goes into both of them, so it's 2 square roots of 10 over 5. Conjugates are going to be a way we use to get rid of that thing on the bottom. So the conjugate of a plus the square root of b is going to be a minus the square root of b. And that will make more sense to you as we get going through this material. Some basic rules you need to know about square roots before we begin. One of them is that the square root of ab would be the same as the square root of a times the square root of b. That's to say, if you had the square root of 18, you could make it the square root of 9 and the square root of 2. Because you had a perfect square in there, 9, then you have 3 square roots of 2. The other thing it does is if you have the square root of a over the square root of b, that means the square root of a divided by the square root of b. Or if it's the square root of a over b, that means you could split them. So in this situation, I'd have the square root of 2 over the square root of 25, which is the square root of 2 over 5. And so you need to know those basic things. What I'm always looking for inside of these numbers is perfect squares. And so when I look at 24, here's a kind of an real easy way to think about it. I don't know. It works for me. 2 times 12, I do a factor tree, those wonderful things that some wonderful 7th grade teacher probably taught you. 2 times 6, 2 times 3. And then I look for pairs because it's squares. There's 2 of them. See, 2 times 2 is 4, and 2 times 3 is 6. And so when I have a pair of 4s there, 2 of them, that gives me a perfect square. So 2 square roots of 6 is how that would reduce. 5 and 18. See, I can multiply 5 times 18 together, and 5 times 18 is 90, so I end up with the square root of 90. Now, inside of the square root of 90, some of you right away see a perfect square being 9. So you have the square root of 9 times the square root of 10, or 3 square roots of 10. Now, the next one is the square root of 9 over the square root of 64. Well, those are both perfect squares, so I end up with 3/8. Okay, so there's just some examples of how those things work. Really, on this stuff, you have to have pretty good number sense to be successful. So You're looking for where's my number sense and how am I doing with it. On this is this rationalizing the denominator thing. You can't have the square root of 3 on the bottom. When I split this to be the square root of 7 and the square root of 3, there's only one thing I can do to the square root of 3 to make it a whole number. That is, multiply by the square root of 3. But if I multiply this bottom by the square root of 3, it will change the value. So I'm going to multiply the top by the square root of 3 also. Because the square root of 3 divided by the square root of 3, it just equals 1. I'm just changing what it looks like. I'm not really changing the value at all. Here I end up with the square root of 21 over 3. If you put this into your calculator and look at the decimal, and this in your calculator and look at the decimal, you'll notice they're the same thing. Now, to get rid of the bottom on this one, the 5 plus the square root of 3, a little more difficult. This is where we're going to use those things that we called conjugates. And that was in our definitions on the first page there. The conjugate of 5 plus the square root of 3 is going to be 5 minus the square root of 3. Now, that's a completely new concept to you. You have not learned that in any other previous course. But that's what a conjugate is. You just know that if it's plus square root of 3, then it's minus square root of 3. So it just changes right in the middle there. The point of it will become a little more obvious to you in a minute. Again, you can do the same thing to the top and the bottom. The top, can I get a whoop whoop? I end up with 20 minus 4 square roots of 3. Bottom, different story. Watch this. 5 plus the square root of 3 times 5 minus the square root of 3. And I think some of you are already saying, oh, look, that's that difference of squares thing. Exactly. This is why we're doing it. Watch what happens. First, 25. Outsides, minus 5 square roots of 3. Insides, plus 5 square roots of 3. Last, minus square root of 3 times the square root of 3. That's the square root of 9. Well, the square root of 9 is just 3. These things in the middle cancel each other out. Square root of 9 is 3. I end up with 25 minus 3, or 22 on the bottom of my fraction. And I end up with 20 minus 4 square roots of 3. Now, one more step that I could do here, because I ended up with all even numbers, 24 and 22. 2 goes into all of them. I could divide everything by 2 and have 10 minus 2 square roots of 3 over 11. 10 minus 2 square roots of 3 over 11. That would be a great answer. That would be a for the day kind of an answer. Take a moment and do questions 1 and 2. Go ahead and pause the video. Okay, so hopefully you did the square root of 50, and maybe you noticed that there's a perfect square in there. Square root of 25 gives you 5 square roots of 2. Don't forget, if you don't see those right away, don't be afraid to do your factor trees and look for pairs. If you see some pairs, you probably have a perfect square. Number 2, I hope you did this. 9, square root of 9 on top, square root of 11 on bottom. Maybe some of you saw that the square root of 9 was 3 right away. If I multiply the top and the bottom by the square root of 11, I get 3 square roots of 11 over 11. And that's a great answer. Again, all you're doing is making it look different so that it fits into what some math guy thought was the best way to write this once upon a time, right? Now, this is all leading up to a bigger skill, and here's the bigger skill that it's leading to. 1/4 y minus 6 quantity squared equals 8, and I need to solve for y. What's my goal? Get y by itself. What's my goal? Get y by itself. Got to have that. Now, a really good first step here, and I know a lot of you guys might not see this, but a great first step is to multiply each side by 4. You see, if I multiply by 4, 4 times 1/4 is 1. So we have y minus 6 quantity squared equals 32. If I square root now both sides, see I'm getting right down to that y. Instead of expanding y minus 6 squared, I square root 32. So I get y minus 6 equals the square root of 32. Let's see if 32 has any perfect squares. 2 times 6, oh, look, that's a perfect square. So now I have 2 I have a square root of 2 and the square root of 16. Well, 16 is 4. 4 square roots of 2. That's the square root of 32. Add 6 to both sides. I have 4 square roots of 2 plus 6. And you can, that gets you to there. The one thing you have to know, though, is this. What number squared equaled 8 can get a little tricky. You see, 4 square roots of 2 squared is going to be 32. Also, negative 4 square roots of 2 equal 32, because when you square it, the negative goes away. So my solutions can be 6 plus 4 square roots of 2, which I think a lot of us could get. The tough one to get, this one right here. 6 minus 4 square roots of 2. That makes it a little tougher. All right, here we go. Big picture here. A water balloon is dropped from a window 59 feet above the sidewalk. How long does it take for the water balloon to hit the sidewalk? Well, gravity is 32 feet per second, so we use negative 1/2 of gravity for dropping something down, so it's negative 16. What was its initial height? 59. I want to know when's it going to hit the ground. Well, the ground's going to be 0, so Z for H and 59 for the current height. If I subtract 59, I get negative 59 over here. And then I divide both sides, subtract 59 from both sides. Then I divide each side by negative 16, and I get 59/16. Next, I square root it, and I end up with the square root of 59 over square root of 16 is just 4. And that ends up being a decimal. I can do it on my calculator real quick. The square root of 59 divided by 16, enter, 1.92. It's going to take almost 2 seconds for that to hit the ground. Now remember, again, what number squared? Well, it's positive and negative 1.92. We can really know that it's silly to say negative 1.9, so we're going to reject 1.9 and move on. All right, go ahead and do 3 and 4. Solve these equations. Oh, look, that was the one I did on the first page. Why don't you do this, look back on the first page and see if you get that. I thought that looked familiar when I did it. Look on the first page, see if you can come up with the answer that I came up with on the left side of your page. And then on this one here it says, suppose that the water balloon is dropped from a height of 27 feet. How long does it take for the balloon to hit the sidewalk? Well, substitute 27 in for 59, and you should get about 1.3 seconds. All right. Thanks for hanging out with us today. Make sure you check out our website. It's at Google, Mr. Emeott Algebra2. And if you Google that, you'll find our website. And if you didn't bring a notebook home, you can get our notes off of there. Thanks a lot. Have a good day, folks.